Now the topic is checking whether two strings are anagram or not. So first of all, we'll see what does it mean by anagram. Then we will see what are the possible procedures one by one. See, anagram are two set of strings which are formed using same set of alphabets. So for example, here I have a word that is a decimal, and same alphabets that are D, E, C, I, M, A, L, same are used here to form another string that is medical. So another word, and it is having same set of alphabet. D is there, E is there, C and I, everything is there. So these are anagrams. So the problem is to check whether two strings are anagram or not. So the first and the foremost thing, check whether two strings are of equal size. If they are different sizes, they cannot be anagram. Right? The first condition. So we assume that they are of equal sizes. Yes, we have taken equal sizes. Otherwise, we have to check. So this is based on assumption they are equal in sizes. Now, how to check whether the strings are having same set of letters? One simple approach is take alphabet from a string and search here. D is found. E, yes it is found. C, yes it is found. I, yes it is found. M, yes it is found here. A, yes it is found here. L, yes. For every letter you can check through this entire string, right? If suppose any one of the letter, this is not L, if it is K, then when you search for K, it is not found. So you can see that they are not anagram. This is simple. I'll put it back, right? So how much time this procedure take? Every letter search here. Searching in this one linear. So linear is n. That is linear search we have to perform. So time for searching is n. Then for this letter also search. This letter how many times? N times. So this is n into n, and this will be big O of n square. So big O of n square time. So the procedure I have shown you, this is the simplest procedure, and this takes order of n square time. So this procedure is time consuming if you do it like this. Then one more thing we have to take care in this one. What is that? See, there are no duplicate alphabets in this one, right? I have not taken any duplicate alphabet. If there are any duplicates, then you have to deal with that complexity. So we have already learned about counting number of duplicates in an array, and we have used the logic. That same logic you can apply here, right? So we have already seen that logic, you have to implement it. Now let us look at the second method, and the second method also we are familiar with, that is using hash table. Yes, this is hash table. I have taken an array of size 26. So already we know why we are taking size 26, and we already know in the previous video we have learned that how we can make use of this hash table. And one thing, all these are lower cases. So if you say no, I have upper cases also and the digits also, special characters also, then you should have a array of size 128. So I have taken only 26. Now how we can make use of this one? Let us see, using hash table, how we can find are these two strings anagram or not. Let us see the procedure. First of all, I will write down the ASCII codes of these lowercase alphabets, right? So this A is 97, this is the ASCII code, right? And the C is 99, D is 100, E is 101, then I is 105, L is 108, M is 109. So these are the ASCII codes of lowercase alphabets that are used in this string, right? I already know the ASCII codes, so you can refer, you can check in Google and you can find out what are the ASCII codes of the alphabets. Now let us see what we have to do next. Scan through this string. So we know how to scan through the string using a for loop. We can go to each and every alphabet. Then for every alphabet, like this is 100. So 100 minus, this is 100 minus 97. So this gives 3. So at 3, increment. So assume that all these are filled with 0. So increment. So it becomes 1. I have not written 0, so that looks congested. So I have just assumed that these are all 0. So this became 1. Now next is 101. So this gives how much? 4. So actually this was 3. So 4, go to index 4 and increment it. Now next is, this is 99. So this will be 2. Go to index 2 and mark it. Then this is 97. If you subtract from this one, then this will be 8. Go to index 8 and increment it. Then go to index, this is 109. 109 minus 97. This will be 12. Go to index 12 and mark it. So this is 12 and this is A. So 97 minus 97 gives a 0. So increment this one. Then this 108. So 108 minus 97 is 11. Go to index 11 and increment it. So see, all these alphabets are unique. There are no duplicates. So we got just 111. Suppose if any character is repeating, then it will increment and it will become 2. So this procedure, we have already seen it earlier for finding duplicates from a string. So this is the same thing. Now what is the next step? Next step, scan through this string, right? Scan through this string. And for each character, M. So it will be index 12. So this actually ASCII code is 109 minus 97 gives 12. Go to index 12 and decrement it. So it became 0. See, it should not become -1. So if already 0 is there, means it is becoming -1, means this alphabet is actually not there, right? So you can stop then and there after subtracting if it becomes -1. Alright, the next alphabet, E. Its ASCII code is 101 and index will be 4. Go there and decrement. So 1 minus 1, 0. So yes, it is not becoming -1. D. Its index will be what? It will be 3. We have already calculated here. So go to 3. So index 3, decrement this. So this is not -1, it is 0, right? Then I. So we are here now. I's ASCII code is 105. Minus 97 is 8. Go to index 8 and decrement it. Then C. C's ASCII code is 99 and its index is 2. Go to index 2 and decrement it. Then A. Decrement it. L. Decrement it. Finish. Now, we never got a -1 value. It means all the characters are as it is available here. So these two strings are anagram. If we got a -1, we can stop then and there. So this is the procedure. By using one string, you can maintain a count in a hash table, and second string you can go on decrementing it. If any number is reducing below 0, that is becoming -1, means it is not found, you can stop. And otherwise you can scan through this entire array once more and see that, confirm that all are zeros, right? If anything is not 0, you can stop and say these are not anagram. So let us do some analysis. How much time it is taking? We are scanning through a first string, so how much time it is? It is linear, so it is n, and this is also linear, so it is n. And then this table we are accessing every time. So how much time? We are not accessing entire table. We are accessing a particular location, right? So accessing this table takes no time because we are not scanning through this entire table, right? So we don't have to include its time. If at all, if you include also, then this will be n plus n plus n. This is 3n and it is order of n. Basically, we are not accessing this, so it is only 2n. So 2n is also big O of n or order of n. So the time is order of n, right? So let us write down the program code for this one. See, we need a hash table. So for that, I will take an array of h size 26 and initialize with a 0. I already have a and b as two strings, that is decimal and medical. Now I should scan through this first string. So using for loop, scan through a first string. For I assign 0 as long as a of I is not equal to null character and I plus plus. And every time what I have to do, whatever the letter is, its ASCII code minus 97, at that index you increment it. So whatever the element is, character is, minus 97, use this as an index of hash table and there increment it by 1. This is first string. Then this is over. Now second string, again I have to scan through a second string. For I assign 0, I, that is b of I is not equal to /0 I plus plus. Then what I have to do every time? whatever the alphabet is, I should decrement at the same place. So the same thing, h of a of I minus 97, at that place minus assign 1. So 1 will be decremented. But after decrementing, check if it has become minus 1. If h of a of I minus 97 is less than 0, if it is less than 0, just print not anagram, not anagram. All right, then also break, come out of this loop. Got it? Continuation, there is no space here. So if this is less than 0, then say not an anagram and come out of the loop. And if we come out of the loop, we may be coming out somewhere around any of these character, we will not be reaching /0. So outside this loop, check if we have reached /0, b of I is equal to null character, then it means everything was perfectly checked. So printf, it's anagram. Printf this one. So this is the procedure. This is a simple code, very simple code, 2 for loops and some conditions. So you can try it by yourself. You can write on the program by yourself. So this is a student exercise, do it by yourself. Right? So that's all with this topic. But one more thing I will show you in this one. What if there are any duplicate alphabets? See, the alphabets are not repeating. D is not repeating, E is not repeating. If there are duplicates, then what? So I'll remove few things and show you this one quickly. Yeah, here I have duplicate letters in a string. Like this is verbose, E, E, and observe E, E is repeating. So how to handle this one? So we don't have to take a special care for this one. The same method will manage this. How? Let us see. This is, when we come on this alphabet E, its ASCII code is 101. So 101 minus 97 is 4. So at index 4 it will become 1. Increment, right? The next time when we get another E, so again at the same index it will become 2 as we are incrementing it. Right? So I am just taking duplicates. Now while we are checking this is string, it's an anagram of that one or not. So for O, B, S, everything we check. Then when we come on E, we go to the same index and decrement it and it will become 1. Then we come to this E, again we'll go to the same index and it will become 0. So it will not be minus 1. So even using hashing, using hash table, we are able to get the duplicates also. Now the last point. You can check whether two strings are anagram or not. If they are not having duplicates, you can use bit set also. The set of bits already we have seen in the previous videos. So you can refer the video. We can use those set of bits also. That is, using bits also we can find out if there are no duplicate letters in a string. Otherwise, in a bit we cannot store 2 or more than 1 we cannot store. So that's the reason hash table is useful for duplicate letters also, but bits are sufficient if there are no duplicates. So that's all in this video. You have to write down these programs and practice them.